Hello guys, today I am going to tell you a method to solve any kind of projectile motion problem. So let's get started with our first example. Consider an inclined plane and let's say a ball at its bottom end is thrown with a velocity u at an angle theta with the ground, and assume phi is the angle of elevation of the inclined plane. If s is the distance at which the ball hits the inclined plane, then to find the value of s, the first thing we need to do is to find the equation of the projectile motion. So taking the initial position of the ball as the origin and the x-axis along the ground and y-axis perpendicular to the ground, we can write the equation as y equal to tan theta x minus g by 2 u square cos square theta into x square, which I have derived in the previous video. So in order to solve this, let's consider some random values to the elevation angle theta, acceleration due to gravity g, and initial velocity u. So we can substitute these values and we can find the equation of the projectile as y equal to x minus 0.4 x square. Let's say it as equation 1. Now we need to consider equation of the inclined plane, which is a straight line making an angle phi with the x-axis. So taking phi as 20 degree, we can find its equation as y equal to 0.364x. Let it be equation 2. So if you take a graph and plot the equation 1, which is y equal to x minus 0.4 x square, then you will get a parabola like this. And if we plot the equation 2, which is a straight line representing the inclined plane, then we can see that the parabola and the straight line intersects at 2 points. One is at the origin, which is the initial position of the ball, and the other point is the final position of the ball where it hits the inclined plane. So these 2 points of intersection can be found out by solving the equations 1 and 2. And on solving, we can find the point of intersection as y equal to 0.579 meters and x equal to 1.59 meters. Since s is taken along the inclined plane, it forms a right angle triangle, and we can find the value of s by using the Pythagoras theorem, which is s equal to root of x square plus y square, which is 1.692 meters. Now if you want to find the time of flight of the ball before it hits the inclined plane, then we have to use the equation x equal to u cos theta into t. Since we know the position x, we can find the time of flight as x by u cos theta, which is equal to 0.45 seconds. Now we'll use the same technique to find the range of the projectile, which is thrown from the top of the building with the initial velocity u at an angle theta. Let the height of the building be h. So if the initial position of the ball is taken as the origin and x-axis along the ground, then the equation of the path is given by y equal to tan theta x minus g by 2 u square cos square theta into x square. Now taking theta equal to 45 degree, u equal to 5 meter per second, g equal to 10 meter per second square, and the height of the building as 10 meters, try to solve this problem for range. On simplifying, you will get the path of the ball as y equal to x minus 0.4 x square. Since the ground is 10 meter below the origin, so the ground plane is taken as y equal to minus 10. And now solving these two equations, we will get the point of intersection at x equal to 6.4 meters. Therefore, range is 6.4 meters. Till now you have seen how to find the range of the projectile. Now we will discuss how to find the velocity at any point in its path. So consider a projectile as shown and v be the velocity at any random point. And let's say v makes an angle alpha with the x-axis. We can resolve this velocity into its components vy and vx. As we have seen in the previous video, vy changes with the position of the time during its time of flight, and vx is a constant value which depends on initial velocity and the angle of projection. Now considering the initial position of the ball as the origin and taking x-axis along the ground, we can write its path as follows. Now if we differentiate this equation with respect to the time, we will get the following equation, where vy equal to dy by dt and vx equal to dx by dt. We can rewrite this equation to find vy by vx. And since we know vy by vx is equal to tan alpha, we can write tan alpha equal to tan theta minus gx by u square cos square theta. And this equation can be used to find the angle made by the velocity with x-axis at any point. Since we know vx is a constant value during its flight and its value is u cos theta, so we can find vy by using the equation vy equal to vx into tan alpha. Thus we can find the total velocity of the ball as v equal to root of vx square plus vy square, which gives the magnitude of the velocity, and the previous equation gives the direction of the velocity. Please subscribe for more videos. Don't forget to like and comment your suggestions. Thank you.